The first four terms of the sequence are 18, 54, 162, and 486. And based on this, we have to show that this is a geometric sequence. Well, what is a geometric sequence? According to the definition, a sequence is geometric if each term can be obtained from the previous one by multiplying by the same non-zero constant. So in other words, this will be geometric if we can get from the 18 to 54 to 162 and to 486 by multiplying by a common term. To show that this is a geometric sequence, we can have 18 times 3 is 54. And then 54 to get 162 we have to multiply by 3, and the same thing with 162 in order to get 486. So based on this, we know that this is geometric because by multiplying each term by 3 we can get the next term. So for part A, this is how you show that this is a geometric sequence. Part B, we have to find the nth term for this geometric sequence. So in order to do this, we have to look at the formula for a geometric sequence. According to the formula for a geometric sequence, the formula is un equals u1 times r to the power of n minus 1, where n is the term number, u1 is the first term, and r is the common ratio. Well, we already know that r is 3 based on our example here on part A, so r equals 3. We know that u1 equals 18 because it's the first term in our sequence. So u1 equals 18, and then we know that n is just n because you're trying to find the expression for the n term, so we just leave that as n. Now all you have to do is plug in back to the formula. Un equals u1, which is 18, times r, which is 3, to the power of n minus 1. You're done. This is your expression for the n term of this geometric sequence. Now in part 2 of B, we're asked to find the value of n given that the n term of the sequence is this number right here. So in order to do this, we can use our answer for part 1 of B, our n term expression, in order to solve this. The way we do this is we make this number equal to this right here. So and now we have to solve for n. Well, as you can see, 18 is inside the parentheses, so we can get rid of that in order to simplify the expression even more. So dividing this side by 18 will give us 59,049 equal to 3 to the power of n minus 1. Now we have to get rid of the exponent in order to solve for the n. So the way we do this is we use log. So log 59,049 equal to n minus 1 log 3. Now as you can see, we have log on each side, so we can actually divide it because the log is actually being multiplied with this. So we divide this log by this log in order to get 10 equals n minus 1, and now we can simply add 1 to this side in order to solve for n. So 11 equals n. So there you go. The value of n for the n term of the sequence for this number is 11. And now on part 3 of our problem here, we're trying to find the sum of the sequence 18, 54, 162, and 486 up to 12 terms. So in order to do this, we're going to have to use a different formula, which is geometric series. And in this formula, will help us find the sum of all these terms up to 12 terms. So the way you do this is you set up your Sn, which in this case the n will be to the 12 because you're trying to find 12 terms, equals u1, which is your first term, so it's 12 times r, which we already found previously to be 3, to the power of n, which is 12 minus 1, and all of this divided by r, which is 3 minus 1. And this is pretty much all you do. Now from here on, you just solve, do the calculations, and you would get S12 to be So there you have it. The sum of all these terms of this sequence, which is geometric up to 12 terms, will be 1,786,960. And all you have to do is use this simple formula.